Hey everybody, this is Larry, this is me going Q3 of the weekly contest 344, number of adjacent elements with the same color. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one, I took 24 minutes and a wrong answer, and to be frank, I just misread the problem. I think I read the problem correctly, but I think I just parsed it in my head incorrectly. Well, whatever. I mean, at the end of the day, I still misread the problem, and I solved a different problem. And you could watch the live portion of it. It actually solves a much more difficult problem. So it maybe is of interest if you, I don't know, if you want to learn something, I guess. But it's a different problem. And I'll tell you what the problem is. And if you're just wanting to look at, I'm just going through my thought process during the contest. If you want to just look at the answer for this one, just skip ahead a little bit. You're smart at home. I mean, you're smart enough to find this video. I trust you. You're smart enough to fast forward to the part where I explain the actual answer. But basically, the way that I just misread it as I misread it in two ways. Well, I misread it in one way, which was that I was counting the number of components where there are at least two elements. Because I thought, I don't know, I kind of misread it a little bit. I thought it was like the number of elements with adjacent elements, like in a component kind of way. I don't know. I just kind of got it mixed up in my head. And that's a way much harder problem. And the way that I did that is by using a sorted list. You could also use like a binary search tree type thing to kind of calculate. Basically, it just becomes a thing where you have a lot of segments and you're merging adjacent segments and removing adjacent segments and so forth. So that's basically what it comes down to. And amusingly, that and of course it gives the wrong answer, which I didn't submit because actually it didn't fit. It didn't pass the example test. But I think I read this and I thought, I don't know, I just kind of misread this answer really because it didn't even pass this. So after I noticed, I was like, oh, that's an easy change because if you look at that solution and you could kind of see it in the live portion, there's a lot of what I call bookkeeping and just kind of maintaining the number of segments and kind of, calculating deltas and merging only adjacent segments and stuff like that. And it is probably correct. I don't know if it ultimately is because once it gets into time limited, but using that algorithm, all I had to do was actually, it's very cool. I mean, it was wrong and it's time limits, but it's very cool in concept in that because I did this hardcore solution, all I had to do was just change a few things to kind of get it to be correct. So that I was very happy about, but still, it time limits exceeded because there is a lot of it is n log n where n is 10 to the 5th or 10 to the 6th, 10 to the 5th, but the constant is just too high, which is fair. And if you're now looking at the real answer, actually, but before that, I'll give you a quick. What was that word? Like basically, I did this thing where I keep a sorted list of all the segments, and then I kind of just add and then merge, add, remove, merge, and all this other stuff. It's pretty funky. If you want to take a look at it, take a look at it. But it's and all I had to do was change this function to calculate the number of adjacent elements. So this was pretty cool, to be honest. Like I thought so, even though it's not correct, but it's something that for me it is something that I want to practice. So in that sense, it's good that I'm getting practice in that, but it's not helping my rating. But the idea here for this problem is noting that when you change one cell, if you read the problem correctly, if you change one cell, you can you only make changes to only two states, really, right? And that's basically the idea here, is that you keep track of all the colors of all the cells, or all the, what do they call it, elements. With you keep track of all the colors, set the initial to 0, and then here initially is that if you look at the adjacent elements, and if the adjacent elements were already the same colors, then and the color is not 0 because otherwise that's no color, then you subtract 1 because changing it at the current index I is going to remove this adjacentness or adjacent element count. And the same for the +1 side, the left and the right. And then you set the color, and then now you can add it back in if it's the same color on the left and on the right, right? And that's pretty much it. This is going to be linear time, linear space. Well, maybe not linear space. It depends how you want to say it. Linear in n, but not linear because n is not the size of the input. N is an input, but not the size of the input, right? So technically, and each q will take q time. So this is technically exponential in n and linear in q, right? So this is actually O of n plus q, right? Time and space, keeping in mind that it takes 2 to the where n is the size of the input, size of the is the input, and the input size is log n, right? So that means that in theory, or if you want to say, it's like 2 to the k plus q or something like this, time and where k is the size of the input representing the number n, right? Maybe it's a little bit pedantic, but just so I could be perfectly pedantic, because this is the internet and someone's going to say I'm wrong, which is fine, but I don't know. I'm wrong a lot, actually. And, this is programming. People are wrong all the time. It's fine. I don't know. The more often you're wrong, the more often you're right, maybe. I don't know. I don't know if that actually is a real thing. But in any case, roughly speaking, it is going to be O of n plus q. And that's pretty much it. Because this is q space, this is n space, this is also n time, and this is q time, right? So n plus q, and yeah, that's all I have for this one. Let me know what you think, and you can watch me solve it live in the next portion. You could fast forward some of it, but I like to say that solution is also beautiful, but for a different problem. So maybe that problem will come up someday and I get to reuse it, but not for this one. And I am a little bit, it is what it is, misreading the problem. Anyway, that's all I have for this one. Let me know what you think. And yeah, you can watch me solve it live during the contest now. Pretty bad typo. That is a pretty bad typo. I was thinking about okay, focus. Silly typo. Hopefully this is a hard contest, otherwise it's a little bit. Okay, focus. Oh. The color, number of adjacent elements of the same color after I've queried. What does that mean? Huh? Is this really that dumb, or I don't get it? I can't believe I made a mistake on the last one. Really silly mistake. Huh. Did I misunderstood this one? Oh. Maybe I misunderstood this. Okay. I think I misunderstood this. Okay, so this is still 1. Number of adjacent elements with the same color. Okay, I misunderstood this one. People got it already, but I actually don't know this one. Third grade. Is it always uncolored? So you could recolor the same thing, right? And they do. I mean, this the n log n one, I guess. Yeah, okay, fine. Let's see. No, this isn't quite right. So people are really good at this. Okay, basically. Yeah, it should be right. Okay. Maybe. I don't know. So if this is the case, then we split it into 3. Yeah. Else, what do we do? C is the thing. Right, okay. And then now, we remerge. Right. Well, a lot of people are getting it. I'm not seeing it. I mean, the way I'm doing it is fine, but it's just such a hard way to do it. Okay. Because we just did it, and then now we look to Jason wants to merge or not. Okay. If don't know if this is the best way to write it, to be honest. This is so bad. This is so bad. What am I doing? Focus. Going crazy crap right now. Okay. I'm so tired. I think this is a technique that people use, but I just am really bad at it. I guess it's the same, it's fine. No, you can't do that anymore. This is a mess, and it might not even be right. No chance this is right. I do know how, I mean, I feel like people do know how to do this, just not me. There's a 2 in one of these answers, so that's definitely wrong. Okay, so I have to, 002, 130, okay. Okay, that's good so far. Still good. One more. That's also good. And then here is the big one. 0, 2, 1, 1 to 3 is 1. Is that true? Oh, I misunderstood this one. I thought components. JSON elements. What is in the JSON elements? They don't really Is it just the size of the components? Maybe I misunderstood this problem, that's why. 560 people, jeez. Yeah, okay. Delta times. Something like that, maybe. Yeah, I'm really behind on this one. -1, I guess. Or whatever. Okay, remove the print statement. Maybe it times out. Am I misread this problem altogether. And 600 people got it. How many people got this one? 145, so I'm really behind. Time limit exceeded. That's kind of crap, but because it is n log n, but maybe with a huge constant. So maybe what I did initially was right, except for that I just didn't factor in well. Okay, fine. I think I misunderstood this one altogether, to be honest, a little bit. See, wait, what? And then this is the before. If I think I just misunderstood this one. That's not quite right. This one wouldn't be time to mix it. I just misunderstood the problem. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.